Welcome to Brain Vision.
Which of the following fractions has a recurring decimal expansion? Option A, 3/8, option B, 1/2, option C, 3/4, option D, 3/5, or is it option E, 8/13? In this question, we are given a list of 5 fractions and asked to determine which of these has a recurring decimal expansion. We can find the decimal expansion of each of the numbers by using a calculator to convert each into a decimal and then use this to see which has a recurring decimal expansion. We do this in steps. First, we want to write the fraction into the calculator. We can do this by using the fraction button or the division button. Next, we type the values of the numerator and denominator into the fraction. Then we press equals. Finally, we press the S to D button to convert the answer into a decimal. If we apply this process to option A, we see that 3/8 is equal to 0.375. This expansion is finite. We can see that it has no recurring digits, so this is not the correct answer. It is not necessary, however, we can write this next to the value to keep track of our calculations. Now we clear our calculator and apply the same process for option B. Doing this gives us that 1/2 is equal to 0.5. Once again, this is not a recurring decimal expansion. Clearing our calculator and then applying this process to option C shows us that 3/4 is equal to 0.75. Once again, this is not a recurring decimal expansion. Clearing our calculator and then applying this process to option D shows us that 3/5 is equal to 0.6. Once again, this is not a recurring decimal expansion. Finally, we can apply this process to option E, and we notice something interesting. At first, it may appear that there is not a repeating expansion. However, the final digit of the calculator's display is rounded up. In fact, the first 6 digits of the expansion are repeating. We can represent this using the dot notation for repeating expansions. We place a dot over the first and last repeating digit. In either case, we see that only option E, 8/13, has a repeating decimal expansion. There is an interesting fact that is beyond the scope of this video to prove about which fractions have finite and which have repeating expansions. It is possible to show that any fraction in the form a over 2 to the nth power times 5 to the mth power for any integer a and natural numbers n and m has a finite decimal expansion. All other fractions have a recurring decimal expansion. Of course, we do not need to use this fact to answer questions like this since we can convert using a calculator.